Welcome to class of Electrodynamics 1. In this class we are going to discuss about the conductors. This topic include the basic properties of the conductor and induced charges. Conductors in an insulator, each electron is attached to a particular atom. In a metallic conductor, by contrast, one or more electrons per atoms are free to move about at will through the material. Because these electrons are free and they can move in either direction, and a perfect conductor would be a material containing unlimited supply of completely free charges. Because in a perfect conductor there are large number of the free charges due to the ionization of atoms, because at the room temperature each atom is ionized. Because a metallic conductor has very less ionization energy, and thus these electrons are ionized and they are not bound to their atoms, their parent atoms, and therefore they have unlimited supply of completely free charges. In real life, no perfect conductor, but substances are amazingly close. You must know that what are these such conductors which are very close to perfect conductors. Here we will discuss the properties of metallic conductors in detail. What does the conductor contain? Each conductor is made of atoms, and this atom contain the ions and electrons. Valence electron. Any conductor always have the zero electric field inside it. If you remove the electron for valence electron from the atoms, you can see that this solid become the ionized and they have the positive charges. But with the electrons, this due to these electrons, the whole solid is the neutral and have no charge on it. On applying external electric field, because each electron is free to move, therefore the electron feel force opposite towards the external electric field, and these electron moves from right to left if the external electric field is applied from left to right, and therefore these electron accumulates on this left hand side of the material, and on the other side the deficiency of the electron is created, and therefore the positive charges are created on the other side and negative charges are created on the left hand side, which produces an internal electric field. You can see if you apply the external electric field, then equal amount of internal electric field is produced in opposite direction. Therefore the net electric field inside the conductor always remains zero. Rho is equal to 0 inside a conductor. It means that there is no volume charge. Inside the conductor the charge density is 0. Here you can see that inside the atom and there are no ions, there are no positive charges or negative charges inside the conductor, because when you apply the external electric field, the electron moves towards the left hand side and creates the negative charges on the surface of the conductor and positive charges on the other surface of the conductor, and inside the volume there is no charge. We can prove this using the Gauss's law. Gauss's law is divergence of E is equal to rho over epsilon naught. Inside a conductor, E is equal to 0. In the previous slide we had discussed that electric field is always 0 inside the conductor. So putting here E is equal to 0, you get 0 is equal to rho over epsilon naught, and so rho is equal to 0 inside the conductor. Due to the application of external field, any net charge resides on the surface. The net charge resides on the surface, not inside the conductor. A conductor is an equipotential. For if we take the 2 points within or on the surface of a given conductor, potential difference is always 0. Suppose you take these 2 points in a conductor. One point is this and other point is this. This point has the potential VA, and this point has the potential VB. So potential difference is VB minus VA is equal to minus integral E dot dl according to the definition. Because E is equal to 0 inside the conductor, so this integral will go to 0, and so we have VB minus VA is equal to 0, and VB will be equal to VA. It means potential at each point of the conductor is the same. There is no potential difference between the different points of the conductors. So we can say that a conductor is an equipotential. Electric field E is perpendicular to the conductor surface. You can see that electric field is always perpendicular to the surface of the conductor. At this, if you take this small element on the surface, then you can say that at this point electric field is perpendicular, and at all these points electric field is perpendicular to the surface. Here this electric field is perpendicular to the surface. At all these points electric field is perpendicular to the surface. Otherwise a charge will immediately flow until it kills the tangential component of field. If it were a tangential electric field, then due to this tangential electric field, the charges started to flow on the surface of the conductor, and there will be no static charges inside the conductor, which it means that the current will be flowing on the surface if the tangential component is not 0. Due to mutual repulsion, the charges spread out as much as possible. Therefore, all the charges resides on the surface of the conductor. Because these charges are free to move inside the conductor, these charges repel each other. Due to repulsion, these charges resides on the surface of the conductor, and in this way the charges gain minimum potential energy because the charges are separated at maximum possible distance. Potential energy depends. We move to the next topic, which is the induced charges. If you hold a plus Q charge near an uncharged conductor, the two will attract one another. Suppose you have a plus a charged conductor which has the plus charge, and this is the another conductor which is uncharged, and is neutral. If you close this positively charged body to this conductor, then what happens? This positively charged conductor attracts the electrons towards itself. Therefore, the negatively charged electrons are attracted towards this positively charged body, and therefore negative charge is induced on the surface of the conductor, and here it creates the deficiency of the electrons, and due to this deficiency positive charge is induced on the further side. Negative charge will be induced on near end of the plus q charge, and positive charge will be induced on the further side of the charged body. In a figure, a charge plus q is placed near a conductor which was originally uncharged. If you take this plus q charge near a conductor which was originally uncharged, then this positive charge q attracts all the electrons towards itself, and therefore on the near side of the plus charge q, negative charge is induced, and on the further side the deficiency of the electron, due to deficiency of the electron, positive charge is created. So such kind of the charge is called the induced charge. And here we take a conductor which has the cavity inside it. Suppose you have a conductor and inside the conductor this is a cavity, mean a hole, this is not a hole, this is the cavity, mean this is a free space inside the conductor, and this is a closed free space inside the conductor. If you place a plus q charge inside the cavity, then what happens? If you take the plus q charge inside the cavity, then this plus q charge attracts the negative charge electrons towards itself, and therefore negative charge is induced on the surface of the cavity inside the meat of the conductor, and this negative charge is distributed uniformly so that the tangential electric field becomes zero. This is due to repulsion of the charges, because the charges repel each other. Therefore, these charges are uniformly distributed on the surface of the cavity. Because all the negatively charged electrons are attracted toward the surface of the cavity, so it creates the positive charge on the further side of the conductor. So positive charge is induced on the surface of the conductor, and this positive charges are uniformly distributed to make the tangential field equal to zero. This is due to the repulsion of the positive charges.